Welcome back to the channel. In today's video, we are going to build a 1300 horsepower rated 400-inch LS. This is actually the old engine block out of my C5 red Corvette. It's a Gen 4 6.0 that we're basically refreshing to do some testing on our engine dyno. So in the previous video, we parallel surfaced the decks in the CNC hone, or the CNC machine. Then we CNC honed the bores to 4.010, so they're 10 over, factory 4-inch. And I've got all of the parts that we're gonna put in this motor laid out on the bench today. So I'm still gonna use the same crankshaft that was in the motor, but I'm gonna put a set of our new Smeding Power Adder H-beam rods in. These are our own designed connecting rod. We have our own ARP 2000 rod bolt. And so we're gonna run this connecting rod in the motor with a set of Icon 2618 coated pistons. This is actually the same rotating kit that we sell. This is our 1300 horsepower rotating kit. And these are the standard Icon piston in that kit. So it has a top thermal barrier coating, it has coated skirts, has a 1.2, 1.2, 3.0 ring pack, and it comes with a set of trend, I believe these are 180, yep, these are 180 wall trend chromoly or tool steel wrist pins. The camshaft I'm going to run in it is one I had on the shelf. It's 250, 262, and the lift is 680 on the intake and 660 on the exhaust, 113 lobe separation angle +4. I'm going to run a Melling 10295 oil pump with a Copo pressure spring and a Rollmaster billet timing set with the roller thrust bearing on the back. Again, we're going to run a stainless steel top ring, a Napier hook second for better oil control, and then about a medium to light tension oil ring. The cylinder heads are a prototype port that we are going to test. The castings are our 11 degree 260 cc head. These are the same heads that I ran on this engine previously, but these have now been opened up to about a 275 cc port. We're going to prototype the port on this engine. And then if we like it, later this year, we're going to come out with a bigger LS3 style cylinder head for these longer stroke LS3 engines. I'm going to run the same valve train in the engine as I was previously. We have a roller tip steel body 1:7 ratio rocker. I did put a new set of trunnions in them. And then we're running the Johnson short travel axle oiling hydraulic roller lifters. So these are all the parts laid out on the table that we're going to put into this Gen 4 6.0 block. Shay is going to be helping me today. I am going to start with bearing clearance. Shay is going to go straight to ring gap, and we will circle back around when it's time to put her together.
That's it.
All right, I'm going to go ahead and knock out main bearing clearance actually. Luckily, since this was a combo that I was already running with the exact same crankshaft, I have a pretty good idea what bearings to put back in it. I'm going to run a half set of standards and a half set of standard X's in this motor. Ideally, I would like to see about 2.6 to 2.8 thou of main clearance. Previously, we ran this engine at about 900 horsepower at the crankshaft with nitrous, and there were absolutely zero signs of bearing cap walk against the block. So that's really encouraging. So in order to check bearing clearance, we're going to mock assemble the engine and torque everything to spec so that everything is stressed and torqued correctly as if it was running for real. And then we'll come back and measure the distance of the housing bore and get our clearance. And in our shop, we like to use CMD thread lubricant. It's much, much cleaner than the ARP stuff, and it doesn't leave this nasty gray, muddy mush in the bottom of your oil pan. This, once it warms up, pretty much becomes one with the oil, and it's a lot cleaner to work with. which is always good when you're inside of an engine. Okay, we've now set the micrometer distance between anvils to be exactly the same diameter as the journal on the crankshaft. I'm now going to zero a dial bore gauge to the micrometer, and then we'll measure the distance in the engine block, and that's our bearing clearance. Okay, across the mains, on the outer four, I'm 2.5 to 2.7, and then I have 2.9 on the thrust, which is perfect for this engine. So now I'm gonna take off the nuts holding down the main caps, pull the caps out, put them back on the bench, and it is now ready for the crankshaft to be installed, but we'll flip it over, and Shay's gonna start ring gap. Okay, while Shay is gapping rings, I'm gonna steal you guys and show you checking rod bearing clearance really quick. So, same process as before. I zeroed the micrometer to the crankshaft journal. I then zeroed my dial bore gauge to the micrometer, and I can now put the dial bore gauge into our Smeding H-beam rods and measure my rod bearing clearance. And we're just gonna go through, again, the bearings are installed in these, everything is torqued to final spec, the rod bolts are stretch checked and everything is perfect. And I've got about 2.5 to 2.8 rod bearing clearance across all 8 rods, so we're right on the money. I'm running a standard bearing full set in the rods, and again, half standard and standard X on the mains. So now we can loosen everything, take it all apart, and we'll be ready for assembly. While Shay's finishing up ring gap, I'm going to assemble the rods and pistons in this rotating kit.
Come feel how even all these feel.
Nope, I trust you.
I want to prove a point. You come here.
Okay.
Put that 28 in all of those. That one's a slightly snugger than the rest of them, but it's very close.
Pretty impressive.
Precision,
Pretty good.
bud.
I'll give you that.
I'm consistent.
Yeah.
Super. All right, second ring's done.
Bearing clearances are checked, piston rings are gapped, deburred, and we have our rod and piston assemblies put together. So starting with the camshaft, let's build this engine. Whee! I always put the camshafts in dry first to check how straight the bearings are. And then I'll come back, lubricate all the journals, and then we can install the thrust plate. These bolts come from GM with Loctite already on them, and they're a countersunk bolt. So there's no need to add extra Loctite. Just put these in, torque them to the factory spec of 18 pounds, and you will be good to go.
To factory spec.
I was giving her the feather in that trigger. I could feel where she was.
I saw it. You're good.
I did not bottom that trigger out. It's on setting 4, son.
I was gonna wait for that one to not turn it all. I was waiting for that top one. Yes. 4.
Y'all are terrible. Back in its home.
Timothy's time to take over.
Crankshaft, camshaft, timing set, and oil pump are all final installed, torqued, in place. It is now time to move on and put rods and pistons in the block.
Timothy's time to take over.
just had to do it.
I
You're
had
good
to.
enough for yourself.
I was good enough.
All right, short block is fully assembled. It's dialed in, everything's perfect. Again, this is our Smeding 1300 horsepower rated rotating kit that I've put inside of my Gen 4 6.0 block. Now it's time to install the 11-degree LS3 style cylinder heads. The pistons are about 10 thousandths out of the hole. We're gonna run a stock GM 50 thou head gasket, so my quench will be 40 thousandths. Final compression ratio on this engine is 11.8 to 1. Ooh, I should probably put lifters in it. Before we put the heads on, don't forget to put your lifters in.
I was like, I don't want to question it. Like, it's not my department.
Now that the cylinder heads are installed on the engine, I'm gonna quickly check push rods. The block did get decked and the heads did get milled just a little to clean everything up. So before we put the old push rods back in, let's do a quick check. looks like the push rods are gonna work from the old combination just fine. So I'm gonna lubricate the tips of the valves, tips of the push rods, and then we can install the valve train. We are almost done with this engine. All the rocker arms are now torqued on this engine. We're gonna roll it over, check our pickup to oil pan depth, and guys, we are almost done. We just have a few more things to do, and this motor will be a sealed up, ready to rip LS. Alrighty, so we're gonna check pickup tube clearance to the pan. I'm gonna walk you guys through this because it's a pretty commonly asked subject. All right, first we'll go ahead and bolt down this side of the pickup tube to the pump to get it seated in the right spot. And then we're just gonna loosely install the pickup stud nut. And I like to get just a big piece of masking tape, and we'll just wrap that right over the pickup tube. Piece of modeling clay. And I just make a little cylinder out of it, stick that on top. And then I always mock up with no gasket. And I will just drop the pan straight over everything. Maybe. And put it against the block, come straight up, and we didn't even touch. So, we want to get this down to about 1/4 to 3/8 of an inch. So what we're going to have to do is stack up some washers in between the pickup tube mounting bracket and the top of the nut, the main stud nut. Sometimes you can get lucky and there's enough play that you can just pop that up and move it out of the way. And let's stack up some washers now. I am using just some ARP hardened washers. Specifically, these are 7/16 ID and 3/4 OD. There's the part number if you're curious, 200-8558. And I'm gonna do 3 because we got a lot of room to go. So we'll throw those on, put that back on. And then we can run our nut back on. Put our clay back on top of the pickup. And drop the pan on, just like so. Squish it down to the block. There we go. That's what we're looking for. So that's about 3/8 of an inch. That's perfect for this setup. So now I'm gonna take this nut back off, Loctite everything, final torque everything, and our pickup tube is final installed in the correct location. All right, cheers. Motor is done. It is a Friday afternoon at the shop. We have been working hard all week, and it feels good to work on something that's our own for once in a while. So, quick recap. Gen 4 6.0 iron block. Actual displacement is 404, or maybe it's 405. We have our Smeding 1300 horse rated rotating kit in it, along with our prototype 11-degree cylinder head. This is a prototype for a bigger version of these heads. This is not the prototype for the first set of 11 degrees. We have a ton of these that work really well. But this is the first prototype with a big port runner version, which we'll see how it does on the dyno, and then we'll come out with it later this year once it goes into production. Camshaft is 252, 260, 680 lift on the intake, 663 on the exhaust. Compression is 11.8 to 1. I'm running that Johnson short travel axle oiling lifter, PAC 1209X valve spring, and a roller tip steel body 1:7:2 ratio rocker arm. Melling 10295 oil pump with a Copo spring. Bearing clearance is, I think it was 2.7 on the mains, 2.5-ish on the rods. Ring gap 25 on the top, 27 on the second. 27 or 28? 28. 28 on the second. So the motor's good for a lot of power. We're just gonna run it naturally aspirated on the dyno. Next video coming in this series in a couple days, we're gonna put it on the dyno. And I actually, when I built this combo originally here at the shop, I never dyno tested it. We were running out of time, so I just threw it straight in the car and we went to the chassis dyno. So I'm really curious what it will make on the dyno. So we're gonna start with a high ram, which is what I ran it with the whole time it existed in my C5. I'm then gonna install a BTR Trinity intake to test and compare. And then we're gonna finish off the testing with the Performance Design PTR high ram carbon replica. And so that'll be really cool. And we actually do have the variable runner trumpets as well if we decide to do more testing on that beast. So yeah, let me know in the comments below how you guys liked the one video engine build versus us splitting it up in the past. We just start to finish this, built it in one sitting. And yeah, subscribe to the channel. Next video will be on the dyno, making some noise. Thank you for watching. We'll see you next time.